afternoon everyone. For this activity, I've decided to make a model which is related to carbohydrates. First off, I'd like to introduce to you the materials that I used in this model. Since we can't go out to buy stuff, I've decided to use woods and barbecue sticks. I asked my grandfather to help me in accomplishing this task. So, carbohydrates, also known as sugars, is a biomolecule or a macromolecule. Macromolecule because it is made up of monomers, building blocks known as monosaccharides, which are linked together to form a polysaccharides. Talking about the carbohydrates, we will be dealing with three elements, which are the carbon, hydrogen, and oxygen. Understanding carbohydrates, we have to remember the 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. And since I figured out that most of my classmates will be doing a polysaccharide, why don't I try making a monosaccharide? Simple yet very important.
Glyceraldehyde is a triose monosaccharide with chemical formula C3H6O3. It is the simplest of all common aldoses. It is a sweet, colorless, crystalline solid that is an intermediate compound in carbohydrate metabolism. The word comes from combining glycerol and aldehyde, as glyceraldehyde is a glycerol with one alcohol group oxidized to an aldehyde.
Glyceraldehyde is one of the simplest sugars which has a role of fundamental metabolite. In my model, the three carbons in C3H6O3 is represented by these black balls, and the three oxygen is represented by the red balls, and the six hydrogens, we have here the blue balls. In addition to that, glyceraldehyde helps scientists in evaluating the nomenclature and structure of other simple sugars such as glucose. This makes glyceraldehyde an important tool which serves as a reference standard for biochemists.